we worked out that it has to be friction, which is counteracting the gravity and keeping the hoop from falling down to the ground. But that leaves two questions. Firstly, for the friction to be strong enough, my body and the hoop have to be pressed together. There has to be a force pressing the body and the hoop together. So I want to know what that force is. Secondly, the hoop is not in contact with my body. Well, there are always bits of the hoop which aren't in contact with my body. And what is keeping them up? So, to try and understand that, we maybe need to understand a bit about how the hoop moves, because it's obviously something to do with the hoop moving, because if it's still, it just goes. So if we think about what would happen if the hoop was not subjected to any forces at all. So it was out in outer space, no gravity, no air, no friction, nothing. So if I let it go then, it would just stay perfectly still, unless I set it off and I gave it a little nudge by mistake, in which case it would float off and it would continue going in the same speed and in the same direction forever, unless somebody applied a force to it. Now, notice I said same speed and same direction. So you have to apply a force to change the speed of an object. Also, you have to apply a force to change the direction of an object. Now, this is the principle, the fact that something will keep on going if you don't do anything to it. Same speed and velocity forever is called inertia. It took a long time for people to work out. But this was what happened, because in Earth we've always got forces. We've got gravity and we've got friction. So if you roll a ball along the ground, it doesn't go on forever. You throw a ball, gravity brings it down, it doesn't go on forever. So, a few examples of inertia. So, if you're sitting in a car or on a bus and it starts suddenly, you're at rest. You're an object with mass, you're at rest. The bus is applying a force to you, but it feels actually like when the bus or the car starts, but you're actually getting shoved back. There's not any force being backwards force, it's actually a forwards force. It's trying to force you forward, but because you want to remain at rest, you feel you're being pushed back. So it's quite confusing. It's also, if you're on a car and you suddenly stop, then you feel yourself going forward, because again, you're a solid object with mass, you want to keep going at the same speed. The seatbelt is stopping you, because otherwise you go straight through the windowsill, straight through the window, and that would be bad. So that's why you should always wear a seatbelt. So that's if you're going straight on and changing your speed. Changing direction, you probably have felt as well, if you're on a bus or in a car, and you go around a corner quite quickly, you feel yourself being shoved over to the sort of outside of the bend. And again, that is the inertia of your body. You want to go in a straight line, the car's going around the corner, and the effect of that is that you feel you're being pushed out. So, what we're talking about with hoops is we're talking about circular motion. And in that case, well, I won't illustrate it with a hoop because I'm in my kitchen and there are things which can be broken. I'll illustrate inertia with this piggy in circular motion. So, remember, principle of inertia, something wants to go in a straight line. So, knowing that, what will happen if I spin piggy like this and let him go? Pigs will fly. Piggy wants to go in a straight line, go straight up, but then gravity pulls him down again. Aha! So, another thing you might notice about Piggy is he's actually going up in the air, so it looks like he's defying gravity. Actually, he wouldn't be able to do that if I wasn't holding this at the centre and stopping him from flying off. Also, you hear sometimes when people talk about circular motion, they talk about centrifugal force. Again, this is a trick that inertia is playing on us. So, to Piggy, he probably feels that there's a force pulling him away from the centre of the circle. Actually, I'm applying a force to stop him from flying away. So, and that's called centripetal force. So that is what I am doing to stop Piggy flying away. This principle of things wanting to fly away, it's used in washing machines, because in the washing machine you have a drum with wet clothes and it spins really, really fast. The drum has holes in, so it keeps the clothes in, but the water wants to fly off and it's allowed to, the clothes aren't. So that's how a spin cycle in your washing machine is used to dry your clothes. It's also a useful principle for getting sauce out of ketchup bottles. You go like this with them and it will go all down into the lid if you hold the right end. So, if we go back to the hoop, if we're going like this, then the hoop is wanting to fly off in any direction it can, but I am stopping it from flying off. So, I'm applying force to the hoop and the body are pushed up together, and that increases the friction, so the hoop doesn't fly away. However, that doesn't answer the question about this bit, which isn't in contact with my body. Why isn't that falling down? Well, I've done the sums on it, but I've forgotten it, of course. But I'll kind of give you an illustration. I'll give you a sort of a simple version and a more complicated version. Then I'll give you some, and I can't explain either of them really very well, but I'll give you some sort of illustration, give you an idea of what I call the aeroplane principle. Now, if we look at my flying pig again, what I'm doing is I'm just moving a little bit, so my hand a little bit, so you can go in a circle. And the faster I make him move, the higher he flies. And it's similar if you've ever been on or you've ever seen a fairground round, I think, called aeroplanes, where they have swings hanging on chains from a sort of roundabout. The roundabout goes round, and the faster it goes, the higher you fly. And it's the same with Piggy. So if Piggy slows down, then Piggy is going down. Piggy, basically it's inertia again. Piggy is wanting to escape, and he's going higher and higher the faster he spins as he tries to escape, and he can't. You can see that he never actually goes completely flat because gravity's still pulling him down. You could also do like this, in which case the inertia is taking them up. Now the force is always being applied by me, by my hand in the middle. So that's what's holding him up actually. So that's otherwise, if I let go, then he's going to fall down. So I'm actually applying the force there. So with the hula hoops, that upward force is coming from the friction, and you have the same principle with the hula hoop. So if I'm going fast, then the hula hoop will spin up and it will be pretty flat. If I let it go slower, then it will start tilting, so the edge will go down and it will just spiral down your body. So to be able to hula hoop, to be able to keep the hoop up, it has to keep going fast enough. But how fast?